Hello, I'm Balaji Rajasekaran from the Department of Electrical Computer Engineering at the University of Florida. So I'm here to present my final project in EEE 6512 Image Processing and Computer Vision. So the title of the project is Action from Time Sequential Images. So here is a small overview of the presentation. So I'll start with the introduction followed by the project objective. Then I'll show you a block diagram of my project implementation. I'll delve deep into the blocks and explain each phase of my project, that is the image alignment, the background extraction, and the foreground masks. After that, I'll be showing two different cases of demos using MATLAB. And after the demos, I'll explain about the challenges I faced during this project implementation, and finally finish it with a conclusion. As the saying goes, a picture is worth 1,000 words. What if the picture can tell you a story instead of 1,000 words? So that's the main theme of this project. This idea is of major interest for sports enthusiasts and professional photographers and publishers. Such pictures convey more detail than a normal photo. You might have seen such pictures in online portals or newspapers. They're a visual treat for viewers. One major drawback of generating such images is the time and effort. So I've highlighted some major drawbacks of this manual method. The picture here is taken from online, which is the action sequence generated by the manual method. So a manual method for generation of action sequence requires some high-end software such as Photoshop. These softwares are basically costly. Moreover, they need a special set of skills to handle these softwares, which again asks for a skilled labor. And finally, these projects require a lot of time and effort. So let's move on to project objective. The main objective of this project is to overcome all the drawbacks suffered in the manual method for generation of action sequence. To develop an algorithm that automatically generates the action sequence from time sequential images. So I've used MATLAB coding for this, and so there are no high-end softwares like Photoshop involved. So this greatly reduces the cost. Moreover, no special skill set is required for this. Anyone can take a picture and just simply run this algorithm to get the required output. And one more major highlight is that this can be achieved in no time. So here is a basic block diagram of my project implementation. It includes the image alignment, the background extraction phase, the foreground masks phase, and finally compiling all the images, the background and the foreground images together to get the final output. The input to this project will be a set of sequence of images taken in burst mode. These can be taken using a high-end DSLR camera or a high-end smartphone. The first step is the image alignment. If the camera is not aligned or the camera is not placed stationary on a stationary medium such as a tripod, then it is susceptible to translational and rotational motions. This makes the images in sequence misaligned from each other. So this as for image alignment phase in a project. So there are a series of sub steps in the image alignment phase. So basically convert the images to grayscale, and later a feature detection technique using surf is performed, which is followed by a feature extraction technique and then a feature matching technique using FLAN. So FLAN stands for Fast Approximate Neighbor Nearest Neighbor Search Library. And this feature matching phase is followed by a homography and then perspective transforms. So the image that goes out of this image alignment phase is aligned with successive images, which makes it easy for the background extraction and the foreground masking phase. Let's move on to the background extraction phase. So for background extraction, the first and last image of the burst mode shot is considered. The first and last images is considered because these two images have the least similarity between them, because they are far apart in time. So the steps that are involved in background extraction are the conversion to HSV, which is followed by determining the difference image and then thresholding this difference image, So finding a proper threshold value was a challenge that we faced during the project. This thresholding is followed by subtracting the mask and then identifying the overlap, if any, and then the largest regions. In case there are any gaps in the final background image, they're all filled at the end of this step. Once the background image is extracted and is ready to use, we go for the foreground masks. Foreground mask identifies the difference from the background. It again thresholds the image. So basically foreground mask technique has the same steps that are involved in the background extraction technique. And finally it is completed with the dilate to adjacent mask step. So let's move on to demo and show how this algorithm works. So I've taken an image sequence, so it has 4 images taken in burst mode. So it has a stationary background. So now let's move on to demo phase. So I've saved all these 4 images in this image sequence folder. I'm just copying and placing it in my current folder. So here are the programs. So it has a compile background function, compile images, foreground by edges, HSV difference, and largest areas, pick foregrounds, and sequence by H3. So the main program is a sequence by H3. So I'm opening it using MATLAB. So here is the code. So I've mentioned the names of all my 4 images here, and I'll run the code now. This main program calls for all the programs, all the functions here, and finally gives me this output. So as we can see, the background is extracted and the foreground is overlapped on it. Since we gave 4 image inputs, we have 4 overlaid foregrounds here. And this is the extracted background image. So as we can see here, this is the output image for sequence 1 and this is the background image obtained. Now let's go on to image 2. The image sequence 1 was taken in a bright environment with a high-end smartphone, but image sequence for demo 2 was taken at artificial lighting, and as we can see, the image is not that sharp. Let's see the performance of this algorithm for this image. So I will remove the image sequence 1 from here. So image sequence 2 as the images, I'll place them in the current folder and I'll open the main program. Since we have only 3 images in the sequence, I'll remove the 4th image, save the program and run it. So here I get my output, and this is the extracted background image. One more difference in this is the human being here becomes part of the background since he is stationary too. So these are output images obtained using sequence 2, and this is the background image. There are some of the challenges that I faced during the project implementation as listed below. So the translation, rotation, and motion of the camera affects the burst mode images, so which in turn affects the alignment, and that in turn affects the background extraction and the foreground masking. So this is one such image. The burst mode shots were taken with a camera that was in motion, and moreover the foregrounds are overlapped. Another challenge phase is the changing light. If there is more than one foreground image, that again poses a challenge. So let's move to conclusion. With the better tuning and enhancements of this algorithm, can get a top quality output. This algorithm is highly user friendly, anyone can use it. Just need to click pictures and upload it and simply use the algorithm to get the output. This algorithm doesn't require any special skill set, and further optimization and better tuning of this algorithm will account for better performance and make it more robust. And thank you for the opportunity.